the vertex formula. In a previous video, and in fact, the video I just finished filming 1 second prior to this, we talked about how to graph things in vertex form. And at the very end of that video, I talked about how to go from vertex form, which looks like this, how to go from vertex form to standard form. The answer is you just FOIL it out and simplify. Going in the reverse direction, starting with standard form and going to vertex form, is a little bit more complicated, but it's honestly not that bad because there is a formula. So if you have a quadratic in standard form like this, the x value of the vertex is x equals -b divided by 2a. To find the y value of the vertex, we need to plug in this x value to the original equation. So let's try it. Let's try it. This problem says to find the vertex, the axis of symmetry, and to put into vertex form. So we're looking for the vertex, the axis of symmetry, and vertex form. We're going to start by finding the x value of the vertex. So that's going to be -b divided by 2a. If we look at the standard form here, our a value is 3, our b value is 6, our c value is 1. It's exactly what it looks like with the standard form, whatever number's in front. Make sure to keep in mind the signs. If this is a minus, it would have been a -6. So -b, -6, divided by 2 times 3. That's -1. The x value of the vertex is -1. The y value of the vertex, that's plugging in -1 into this original equation. All right, so we have y equals 3 times -1 squared plus 6 times -1 plus 1. Let's see, so we have 3 minus 6 plus 1. That is going to give me -2. The y value is -2. The axis of symmetry is always going to be x equals the x value of the vertex. So this is x equals -1. To find the vertex form, it's super simple. Remember, we're looking for y equals a times x minus h quantity squared plus k. Really, what we need is this a value right here. But the really cool thing is The A value in vertex form is the very same one as the A value in standard form. So this 3 out front is the same 3 that would go out front here. So 3 times x, we use the opposite sign of h. So this is plus 1, quantity squared, minus 2. So here we have it. Y equals 3 times x plus 1, quantity squared, minus 2. Bam. Easy peasy. If you were to FOIL this guy out, you would get back to this guy over here. So those are the same equation. Let's look at one more example. Determine, without graphing, whether the quadratic function y equals negative 2x squared plus 8x plus 3 has a maximum value or a minimum value, and then find that value. First of all, right off the get-go, our a value is negative 2. Right? A is equal to negative 2, which is negative. If a is negative, that means it opens down. If it opens down, just draw a small picture, that means it has a maximum. It's on the top of a hill. So it definitely has a maximum. It's just a matter of what is that maximum value. The maximum or minimum value of a parabola, a quadratic, is always going to be the y value of the vertex. So we need to find the x value of the vertex so that we can plug it back into the original equation and find the y value of the vertex. Can I cheat and duplicate? Yes, I can. There we go. So the x value of the vertex, that's x equals negative b divided by 2a. The values of our a, b, and c. A is negative 2, b is 8, c is 3. So this is negative 8 divided by 2 times negative 2. Negative 8 divided by negative 4 is positive 2. For the y value of the vertex, we are taking this x value and we're plugging it right into this equation here. So y equals negative 2, and then instead of x, we're doing 2 squared plus 8 times 2 plus 3. Let's see, this will be negative 8 plus 16 plus 3. That's going to be positive 11. Positive 11. So the vertex is at 2 comma 11. Which means that the maximum value is 11. Bam. So that is the Vertex formula. I'm going to make one more video. I forgot what I named that video. I'm naming it, I don't know, graphing projects in standard form. Basically, I'm just going to be doing the same type of problems I did when we had it in Vertex form, only with it in standard form and using the Vertex formula. So if you're still kind of struggling with this Vertex formula thing, make sure to check out the next video that I'm about to film right now. All right, bye.